sun just came out. Last one of these. Awesome. Glad you're enjoying them. Let me just send off a quick message to our community moderator. Cool. Well, for those of you just joining in, my name is Winston Moy. I'll be hosting the Carbide 3D Office Hours live stream for today. This is just something we're doing to help people pass time and teach something new. Today we're going to go over how to make a basic branding iron in Fusion 360. So, I don't know if you guys saw this on Instagram, but a couple days ago I made one of, let me switch to thumbnail view, one of these guys on the CNC. So this is just a piece of brass rod stock that is that's been turned. I parted it off. On the back side there is a 1/4 thread, so that's how I'm bolting this to a piece of MDF to hold on the CNC. And so everything that I'm going to do today assumes that you just have MDF held in some way. It could be a square shape, a rectangular shape, round shape. Just as long as you can hold it on your CNC, you can machine it. Brass is a material that's probably 30 to 50% tougher than aluminum, at least 60-61. So all of the speeds and feeds that you have in Carbide Create for aluminum, if you just dial them back a little, if you reduce the depth of cut by maybe 30% and reduce your feed rate by maybe 20%, that should get you in the ballpark of something you can use for brass. But I'll show you the speeds and feeds that I ended up using for this project, and also some of the other permutations that I did. Something like the Carbide 3D logo, you could machine pretty much with just a flat end mill, but there are some features that require a slightly more detailed tool. So up in the end of the C shape, there's a really tight radius turn that you wouldn't be able to do with a 16th inch end mill, and even a 1/32 inch end mill would kind of be pushing it. So I'll show you some little trick you can do in Fusion to knock out these little corners, and hopefully it'll work for whatever logo you guys have. Alright, so we got Carbide answers up in the chat, so if you guys have any easy questions, throw them our way, and we'll answer them for you as best we can. This will be available later, so if you go to the Carbide 3D channel, and we might also just straight up publish these as public, but right now if you scroll down to the Carbide Office Hours playlist, all of these will be available. So you'll be able to check back and review anything that you might have missed. Cool. Any specific type of brass? So that's a question we get a lot, and one of the best resources that I can think of just really easily is McMaster-Carr. Online Metals has a guide as well, but if you go to McMaster, if you start shopping for raw materials, scroll down, scroll down, scroll down. If you go to metals, you pick out brass, bronze, anything. If you dial in, there's an about section that you click on, and it just gives you a really easy list that you can look at to say, like, these are the grades we sell, and each of these has different characteristics, which ones are ultra machinable. For copper, it's the 145 alloy. For brass, 360 is an easier one. But these are, you have to also take these with a grain of salt, because just because it's machinable doesn't mean it's good for your applications. Some of these, they're machinable, but that's because they alloy in certain things that you may not want. So if you're making jewelry, I believe some of these alloys may have a small amount of lead in them, so you wouldn't want that for long-term skin contact. But for a branding iron, you really don't care. So you can use this guide to help you find a good alloy, but sometimes you just might have to pick a less desirable alloy because of the application that you're doing, or if you need something with more or less corrosion resistance, higher strength, different things like that. So without further ado, let's get started. So I'm going to basically recreate the top half of this branding iron. I'm not going to worry about the back side because I'm just going to assume that whatever chunk of brass you've cut off, you've got it threaded or held in some way. The only parts that you really need to machine are the parts that are going to contact the wood. So I'm going to start blank canvas, Fusion 360. I like to sketch on the XY plane and leave the Z vertical, just so that this is oriented just like how I would machine it. I'm going to start with a 1-inch diameter circle, because that is how large my stock is. So with just a circle drawn out, I'm going to extrude it up, and because this doesn't need to be accurate, we're not machining the whole chunk of brass. This can just be a placeholder piece. I'm going to say 1/2 inch. And then on the top, I will create another sketch, and then I'm going to bring in a SVG or DXF. So you can bring in any other vector graphic that you might have. In this case, I've got a DXF, and it's going to be in my folder of Carbide Office Hours Supplementary Material, C3D logo, and import that in. And this just happens to be a scale that's pretty close. Let me snap this to the edge of the screen. If you bring in a DXF, those files have an innate scaling in them, and you really don't have as much control over how to scale these when you import it. If I were to import an SVG, so let me try a different one, and you bring it in, you actually do have a scaling control that you can use. So SVG, DXF, they both work. You can scale the DXF after the fact, but the DXF is the file format you natively export from Fusion. So if you're trying to bring in another sketch from a part that you've made and you're trying to align it, DXF might be what you want, and it'll also be scaled 1-to-1 with the whatever it is that you're trying to make a part for. So I'm going to just bring this in, and I'm going to scale this down just a little bit. So I don't want to select the outside profile of the cylinder that I'm sketching on. So I'll just select everything, or I'll just double click on the contours, holding Shift to select these two together. Then I'm going to go into the Modify tools, and then I'm going to use the Scale Sketch tool. So in here, I've selected all the elements of my sketch that I'm trying to scale. The point that I want to scale around will be the origin, just so everything is centered. I'll select that, and then I can increase or decrease the size. And I think maybe about, let's go 0.7. Hit OK, and then finish out that sketch. So now I've got two choices. I can either extrude this up, or I can extrude everything else down. I think I'm probably going to extrude stuff down, but that's entirely up to you. So I'm going to say, let's reduce this by 0.05 inches, maybe 0.0625. And the amount that you offset these faces is kind of up to you. If you have really tiny features, it's going to be hard to get a really deep but detailed pocket. The reason you want to offset these faces a little more is that as you're pressing this branding iron into wood, it's going to sink in a little bit. And as this back face gets closer and closer, that radiant heat is going to also burn the wood. So the more you can separate these faces, the sharper the details you're going to get. So at least 1 millimeter, preferably 1.5 millimeters to 2 millimeters would be much preferable. And yes, as you can tell, I am wearing the fancy Carbide 3D swag. So not for sale, but just so you know, the elite people in the community have them. If you participate in our community challenges, you have a chance to win some of this. So definitely go check it out. Facebook group and also the forums. Where are we? Okay, so we've got the front of our branding iron extruded out. There's another feature that I like to put into branding irons like this. And so if you can see in the image, I have two flats machined on this. This is just so that it's really hard to orient around branding iron, especially when you can't see the logo and you're just pressing this down. Those flats, you can either grab them with like a pair of pliers or a wrench to help orient it and give you a little extra leverage, make sure you're stamping it flat, or you can just take like a metal rule or something as a straight edge and just use that as a guide to bring down the branding iron. Because the worst thing that can happen is if you have, I don't have a picture of it. Actually, I do have a, let's go to the video. I branded the topographic carving I made last week, and you can see the logo is just a tiny bit crooked, and it really bothers me, and that's because I was lazy and I didn't use that little alignment feature. But round branding irons, probably better to have some sort of feature in there to help guide you. So I'm going to turn on my sketching planes in the origin again, and then I'm going to hold down my left click until I can select anything that is beneath the cursor. In this case, I want to select the YZ plane, and then I will sketch on that. And then I'm going to draw in just a little cutout here that I can just extrude and push through everything. And the way I'll do that is with a 2D rectangle. And then I'm going to define how far I want the flat to flat distance to be. So in this case, I think 0.8 inches is fine, so half of that will be 0.4. And then how deep do I want this cutout to be? I'm going to reference this from the top surface of the pocketed out area, and let's say 0.25 inches. And I think that should fully define everything we need right now. So I'm going to select the sketch that we made. I'm going to extrude that out. And then right now it's in just a one-sided mode, so I can cut out everything here. I could mirror this. It's easier if I just do it symmetrically though. So now I can extrude and cut from both sides. And then since I want the same cutout on the other side in case I need to flip this over, I will mirror this feature, the extruded cut feature. Select mirror. And the mirror plane will be the XZ plane. And then now we've got two flats here. One other thing I forgot to mention, when I was bringing in the DXF, we'll just create a quick sketch again. When you bring in a DXF, you saw that I didn't have a lot of options for manipulating it or scaling it or anything. One of the things you might really want to do is invert it, because when you're branding something, you're mirroring it basically. If you bring in an SVG, I believe there is an option to flip it, horizontal flip or vertical flip. Horizontal is probably the one you want. So you will want to pay attention to that when you're making a branding iron. I speak from experience when I say that when you get a backwards branding iron, it's pretty useless. All right, let's continue. I'm going to save just because I don't trust Fusion for this. And then, let's see. I think we're pretty much ready to make toolpaths for this. Let's see. I mentioned detailing can be difficult. Can you give an example of what types of detailing would fall into that category? So if you have fine text, that is one area. The other thing is this little radius. If you look and you measure it, that diameter is 0.018 inches, which is, you would need a 1/64 inch end mill or something below 0.5 millimeter in order to cut this out. So you wouldn't be able to define this feature using the tools we have in our, or using the flat end mills we have in our tool library. You could either purchase a really skinny end mill that would be super duper fragile, which I would not recommend because you need to pocket this out several times the diameter of that end mill down to reach the pocket. But there are some hacks you can use to get around that. So I'm going to stop measuring. I'm going to finish out that sketch. Let's make some toolpaths. So first thing to do when you start is to make a new setup. Because I know I'm starting from rod stock, I don't need Fusion to think that I have all this extra material in the corners. So I'm going to go into the stock settings, and I'm not going to say relative size box, I'm going to say relative size cylinder. And so now Fusion thinks I have cylindrical stock. Perfect. I'm going to say my radial stock offset is maybe 0.01 inches. It's always nice to tell Fusion that there's a little extra material there, so that it doesn't crash into your stock if you don't set your origin perfectly. There's a couple other things I want to change here. I want to zero off the top center of my cylinder, just because it's hard to find an arbitrary corner floating out in the middle of nowhere. And I'm going to be zeroing off the top of my stock. And then I'm also going to say I have a little bit of stock on top that I need to face off. So front side stock offset, let's go 0.004. So basically thickness of a sheet of paper. We're just going to trim off the top of the stock because it might not be perfectly flat. If you're cutting this stock on like a bandsaw or something and you have even more variance in that height, you might want to increase that to maybe 0.01 inches. Just add a little more in there. You can always rerun the facing operation to bring it down if there are some craggly areas where you might not have flattened completely. Okay. Did I learn Fusion 360 by trial and error, or did I do an online course? So back in college, I learned Creo, Pro Engineer. Now it's just Creo. When I went to grad school, I learned SolidWorks. That was self-taught. When I went to work in industry, I learned Inventor, and that was also self-taught. If you learn one, the fundamentals are all pretty similar, so you can usually bring them from software to software. If you don't have, like, if you've just used like SketchUp or something your whole life, or like Tinkercad, the learning curve will be a lot steeper. I would recommend courses by Lars Christensen, NYC CNC, and Titans of CNC if you want some more structured learning. Right now there's also the content by Autodesk itself is also pretty good. Their tutorials are pretty well explained, pretty clear, and cover a broad range of subjects. There's also some resources online, like through Skillshare or whatever, that you can get lessons through. I think Pluralsight is currently free for the month of April, so if you want to get some courses, you can learn through there as well. But you can always hit me up later for some additional resources. Just find me on Instagram or the Shapeoko Instagram account. So we've got a setup. We've got stock encapsulated. The first thing I'm going to do is I'm going to put a facing operation on top of this just to remove all of the material that's above our branding iron head. So I'm going to do facing operation from the 2D menu. I'm going to select a, let's see, let's go 274 single flute end mill. And then the cutting feed rates, feed per tooth, whatever, these are maybe a little fast. I think the rule of thumb I heard is for a 0.125 inch end mill, try a feed per tooth of like 0.00125, and then for a depth of cut do like 0.0125. So that 125 sort of carries over. Same thing kind of works for 0.0625. It's just a power of 10. But these are more for aluminum than anything else. So because this is brass, we don't really need multiple depths here for the facing, but I'll do it anyway. Like I said, you can pick an aluminum speeds and feeds parameter and then just back off on the depth of cut. So I'm going to say like 0.007, 7 thou. And then the feed rate I'll back off to, let's say, 1 thou per tooth, maybe a little less. Let's go 14 inches per minute. And then at some point I'll look back at my original file and see what I did there and compare if just making this up on the fly actually matched what I found worked. I just lost everything because I wasn't paying attention and I didn't finish out this toolpath. So 14 inches per minute. And then one thing I like to do, I like to reduce my lead in feed rate and lead out. So lead out is when you're leaving a cut. And generally, it still means you're touching the material a little bit. So I never want my lead out to be faster than my cutting feed rate. So one of the tricks I do is I set my default to match my cutting feed rate. There's a lot of little things that you can tweak in Fusion under the hood, and one of the things is these feed rates. So if I go into Edit Expression, I can define a formula for how I set my feed rate. And in this case, I want my lead out feed rate to be the same as my cutting feed rate. And you can, once you type that in, once you save it, you can make that the default. For my lead in feed rate, I have set that to default to a fraction of my cutting feed rate. So here it's 75%. Same with ramping, and plunge can be 15. Prismatic text I did a long time ago, and that's just a matter of taking a really, I'm assuming you mean like triangular, like angled faces and stuff. You can take a really cheap engraving tool and just use that sort of like a V cutter. It's not ideal in metals, but it will work. And I'll show you something similar later on once we start doing toolpathing for the inside of this. So facing, multiple depths, 7th thou. And so we get a toolpath that comes through, trims off extra material in 2 passes. There are some additional parameters in the facing operation I like to play with. Sometimes I will tell it to overshoot the material. So pretend the stock is a little wider than it is, or to extend the parallel passes, just to make sure that you've gone off the material before you turn around, if you really don't want to see swirls on the face of your material. Doesn't matter here, so I'll just undo that. And we're just left with a simple facing toolpath. Next thing is just dump an adaptive clear over everything. It is probably the easiest way to get through stuff, and it works best when you've modeled your stock exactly. And it's nice when you have access to the material from the outside, or the model. So if I throw an adaptive toolpath on this, and I'm just going to leave all the default parameters in there just to see what it looks like. When you do that, it gives you an idea of like which parameters you need to tweak. So looking at this, it actually looks pretty good. One of the things I would do is I would force the bottom of that toolpath to stop. If I pick from selection and then select this face, the toolpath won't calculate below that point. So if you have a little extra stock modeled, it's going to try and circle around the entire branding iron all the way to the bottom. So this will just stop it because that ledge is the last thing we need to machine. For an adaptive toolpath, I'm just going to guesstimate about 20 inches per minute. Why 3D versus 2D? So 3D adaptive toolpaths are model aware. If you pick a 2D adaptive toolpath, you're going to have to pick regions, pockets, or this ledge to machine, and it's going to do them in a different way. A 3D adaptive toolpath is just going to look at the model and automatically remove all the material that it can. The 2D is a little quicker to calculate because it's not doing as much, it's focused on certain areas, but the 3D is sort of just a one-stop shop for everything. Which Carbide 3D end mills do I recommend for milling brass, or is it easier to ask end mills? So we have a line of end mills that are good for a variety of things, and we advertise the end mills ending in -Z, the zirconium nitride coated end mills for aluminum. Zirconium nitride works for basically anything non-ferrous. So aluminum is good, and it's also pretty good on copper-based alloys. So copper itself, brass, bronze. So these are pretty much general purpose for all metals, unless you're crazy and you're machining steel, in which case you're going to want aluminum titanium nitride, Altin, or some of the other similar coatings like that. But zirconium nitride, pretty safe bet for a bunch of things. Also, crystal, that N should be capitalized, so just fix that when you have a chance. Anyway, so 2D adaptive, if you pick out these specific regions, you can use it, but if you do something like this, it's not as efficient. So the adaptive, it will work, see, on the first layer, it goes all the way out to the edge of the material, whereas in the 2D adaptive, it stops at the edge of this face. So 3D just looks at everything holistically. 2D, it works based on contours, based on faces only. So let's see, 3D toolpath. I'm going to tweak this a little bit more. I like to run my stock to leave as close to the like near net shape as I can. I usually leave maybe at most 10 thou radial stock to leave. In this case, 1/8 inch end mill. The cutting forces are going to be pretty controlled. I'm not worried about the tool deflecting a lot. I'm going to go 8 thou. And then I've got my axial stock to leave set to 4 thou. I also have that as an expression, so whatever my radial stock to leave is divided by 2. I like that ratio personally. It's worked all right for me. So the end mill is going to stop 8 thou from any of the flat faces, and it's going to stop 4 thou off the bottom floors. One other thing that you might want to enable for things with a lot of flat shapes is flat area detection, because right now, when these toolpaths are coming in, it's going down by a fixed step down, and then any of the remainder between each layer is ignored. So if this were like 0.06 inches down from the top, and I was stepping down in 0.04 inch increments, I would miss 0.02 inches of stuff there, and when I came in with a finishing toolpath, there might be an unexpected amount of material there, despite the fact that I programmed this to only leave 4 thou of stock to leave. So if you do flat area detection, you can say your minimum step down can be like 0.01, so it'll get, the remainder will be at most 0.01 inches. That will sometimes throw in an intermediate path in order to remove a little extra material. Is that area removed on the sides to remove material to reduce time to heat up? You could totally use hexagonal stock. You could buy hex stock, you could machine it into hex stock. This is just to give me a flat reference surface to ensure that when I brand this, it's horizontal and upright, perpendicular, whatever. So adaptive brings us to this point. You'll notice that nothing has touched the inside here because the 1/8 inch end mill is too large for it. But while we still have the 1/8 inch end mill installed, I want to finish as much as I can on this model. So I would say you can hit all the vertical walls with a 2D contour toolpath. So I'm going to pick that, I'm going to pick this, and I'm going to pick this. So these faces, I'm going to contour with an 1/8 inch end mill. For finishing like this, I like about a 14 inch per minute feed rate, and we're going to do multiple depths of cut, maybe 0.03. And then when you're working with lighter weight machines, you have to really worry about deflection if you care about surface finishes. Here, we really don't, because the only thing that matters is you have a big flat face on the top that can stamp wood. But just to make it a little prettier, I'm going to stop the contour toolpath 4 thou above the floor. Don't need radial stock to leave because we're trying to finish this up, bring the dimensions as close to final as possible, but we do want a little bit below the end mill. And I'll show you why with a simulation. So if we run a simulation of this toolpath, I'll turn on the stock. I'll make it transparent. After the first two toolpaths, this is what's left for the tool to do. So I'm just going to run that, and you can see what it's doing. And as it's coming through, it's going to be pushing through material, but there is some material underneath the end mill. This is what was left over from the adaptive toolpath. So if you run this finishing contour all the way down the bottom, it's hitting extra material than when it was finishing the rest of the walls. So in those cases, the amount of force on the end mill changes, and the surface finish you get is going to be affected. So by stopping just where the adaptive toolpath finished, and then finishing the rest with a pocketing toolpath, you can really control the forces and make sure that you get a smooth surface on the walls. Yeah, remembering simulation settings would be nice, but I don't have enough friends in Autodesk to fix that. So I'm going to finish the walls with a 2D contour, but not touch the floors. And then I'm going to come back with a pocketing toolpath and touch up these faces. So 2D pocket, select that face, select that face, select that face, and then we're going to do the opposite of what we did with the contour. We're going to leave radial stock to leave, just a tiny bit, like 0.002 inches, no axial stock to leave, and then that will clean up everything else. And if you're really paranoid that technically there's a little bit of material that's left over, you could always go in with a spring pass. So technically, if you cut everything away, there's a really, really tiny ledge of material down in this corner. You could just come back with a contour and clean that up. But I like to segregate my toolpaths for the contours to only touch the walls, and for the pockets to only touch the floors. So that gets us, I think, everything we need to do with the 1/8 inch end mill. If you want, you can do a pocket finish over this just to smooth out the surface texture, but the facing operation should leave a pretty consistent surface finish. You can also polish this up with like 800 grit sandpaper after you're done. And so now we're ready to do the detail work with a 1/16 inch end mill. And one of the lucky things about the sizing of this logo is that the distance from here to here is less than 1/8 of an inch. So we don't need to pocket this out. We can just contour following the inside profile of this cutout. And that won't leave like any islands or anything in the middle. So 2D contour with a 1/16 inch end mill. I'm going to say we're going to use our 112, but really I'll be using the 112Z. And then I'm going to reduce these feed rates to about 10 inches per minute, resetting my lead-in, lead-outs to be a fraction of 10 inches per minute. And then multiple depths. The 1/16 inch is going to be more fragile than the 1/8 inch, so naturally you want to reduce that depth of cut. 0.0625 inches, how about 0.006? You could put extra significant figures, it really doesn't matter. 6 thou depth of cut, make that even, and we want to follow that inner contour. So this is going to come in, it's going to dip in and then sort of do a little turn into the cut. Oh, this is also starting a little higher than we need it to. So right now, most toolpaths default to starting at the stock top, which if you remember, we modeled a little extra material over this, but we really don't need it to start cutting until it reaches the top of the model. So I'm going to change the top height to model top, and now this toolpath will start underneath the surface of the brass. With a 2D contour like this, that lead-in maneuver, it's still much better than what you can do in like Carbide Create, which just shoves the end mill straight into metal. It's fine for wood, it's fine for plastic. If you're going to do metal, ramping moves are really, really nice. This lead-in maneuver is okay. I would prefer a ramping move. So if you go to the under lead-ins in the last tab of a contour toolpath, there's a ramp option. I like to ramp in for aluminum and brass at about 1.5 to 2 degrees. So let's split the difference, let's say 1.7 degrees. And then if we run that now, we have a toolpath that starts really high up for no good reason. That's because the ramp clearance height, where it starts ramping from, is obscenely high. Let's change that to 0.01 inches. And so now it'll start ramping much closer to the stock and not waste a ton of time. And that's good. At the end, once it sort of spirals its way down, it's going to leave the material, retract. But if you really want to achieve the best surface finish, you're going to want to run a finishing pass. So if we redo this toolpath, let's add 4 thou of stock to leave. And then we come back with a finishing pass for this toolpath. I'm just going to duplicate this and then just really quickly remove the stock to leave and then increase our depth of cut, because you're not running through the material with 100% of the end mill. It's just barely kissing the edges. We can afford to take a more aggressive cut. Let's say 0.015 inches. This will be a much faster cut. Whoops. This is before, this is after. It's a very subtle difference there. Roughing toolpath, finishing toolpath. Small difference, but again, you can see that at the end of this, it is not going to clear out the ends of our C in the Carbide logo. And like I was saying before, even if you had a 1/32 inch end mill, you're not going to be able to get in there. This radius is less than 0.02 inches. The best way would be to use a much finer point tapered end mill, and Fusion is actually really awesome in that it lets us do that. So if you apply a 2D contour toolpath using let's say something like our 501 engraver, which is a 60-degree point PCB engraving tool, totally useful for more than just engraving PCBs, and I select that little radius to work on. If you click a contour, you click on it again, you can select subsets of it or custom chains. I'm going to select an open contour so that only that little radius is selected. I'll accept that. I will add this radius over on this side. And I hit OK. This tool will only machine out that radius, which is not a lot right now. Also, I picked the top of it, so it's going to try and stop at the top of that radius. I want the bottom height where this contour cuts, where the end mill will finish, to be below the surface of my model. So I'm going to say go 0.04 inches below the surface, and then again, don't start cutting until you hit the top of the model. And what Fusion's going to do, once it finishes calculating, it did, and nothing showed up, is if the end mill finishes all the way down there, it's not going to have, there's basically nothing for it to cut, because it's restricted to touching such a small subset of this model. We need to add a little bit of tangential extension, so I'm going to say 0.03, and that just means that after following this little curve, it'll allow itself to go just a little bit further. And that's going to give us a toolpath that looks like, well, not a lot. That's because we don't have multiple depths of cut set. So I'm going to do 0.01 inches. Sure, even step down. Let's see what that gives us. So that's going to give us a toolpath that moves down, that respects the taper of the end mill, and then removes as much as it can from these corners. So I'm going to simulate this with the facing operation so we don't see the top of the stock. I'm going to show the, let's pick the pocket, the finishing tool paths, and simulate that. Tool transparent. So after the first operation, second operation, and then the finishing of that contour, this is everything that the tapered cutter needs to deal with, that remaining material in that corner. So what this tool is going to do is it's going to use the tip of the end mill, remove as much as it can, and then go down a little further, remove a little more, and then remove a little more, and it's just not doing anything at that point. But it clears out that corner so that there is no material here to contact the wood, and you get a nice crisp engraving with this branding iron. And then it's going to do it on both sides, and that's great. If you want to do this with just a really cheap like PCB engraver that doesn't have a radius point at the end, you can use the engraving operation, so just like V-carving, but in Fusion 360. That'll work too, but what that's going to do is it's going to drag the cutter diagonally up to this point, so you don't get little steps there that you would see. If you have a super rigid machine, if you have a high quality tool, you can achieve a V-carve sort of in metal just like you would in wood, but it's just not ideal in most cases. So this quick workaround gets us a well-defined corner, and when you export that, that toolpath is going to look like this. So here you can see the stock that I'm preparing. They're just little, about 1 inch tall pieces of brass rod stock, and I'm just tightening them down with a 1/4-20 bolt, super tight, because I don't want these rotating. And then after that, that's just leftover MDF that I have, and I'm just going to screw it down to my wasteboard. The brass blanks, you can just turn them down on a really cheap lathe, or you could use a hacksaw or something, and then just get the faces flat, drill and tap the holes for 1/4-20 or whatever you want. I know some branding irons, I think, use like 10-24 threads or something, like the little electric ones that you can plug in. I'm using a piece of paper to find my 0 point on the stock, just to find the outside, and then using those two coordinates I can calculate where the middle is. You see the facing, you see the adaptive toolpath working its magic. And then I did something a little different here. Instead of using a flat bottom little ledge, I tried to get a little fancy and make it radiused. So you'll see me coming back later with a 1/4 inch ball end mill, which it works all right, but it's really kind of unnecessary in the grand scheme of things. That flat bottom pocket is just more efficient. So I used 3 passes to clean that up. That toolpath I'm using roughing passes enabled. I'll show you how I set that up later. And then now I'm switching tools to the 1/16 inch end mill. And then this tool will cut out the inside using a contour with some stock to leave, and then a finishing contour. And this toolpath is pretty low stress because it's giving itself plenty of room. As it's cutting, it's just basically leaving ample room for chips to get out of there. This is the engraving tool. And then the one thing you'll notice with this tool, which it's hard to see on the video, is that little, that C area, the tip that I had cut out with the 501, isn't perfect. You can see that it's flared out a little bit because the engraver was cutting more material than it should have. And so the reason this happens is because I was using a really old engraver. When you're touching off these tools on like a bit setter, or even just setting it with a piece of paper, if that tip is chipped or eroded in any way, That means the tip of the end mill that gets that your coordinates are calculated off of is much closer to the tapered walls of the cutter. Everything gets shifted. Everything that the cutter does is shifted down effectively. The wider portions of the end mill are brought further down because that tip was missing. It wasn't calculated by the bit setter, and so it's just punching deeper into the material than Fusion expects. So if you're using an older engraver like that, you might want to leave just a little bit of stock to leave, and then creep up on it just so that these the different walls left by the different end mills will all match up. You can creep up on that. So if I had left maybe 0.002 inches of stock to leave, radial stock to leave, nothing on axial, that would have kept my toolpath just a little bit inside, and then not over machined some of this brass. Or you could just use a brand new end mill every single time, or if you're super fancy, you have an optical comparator microscope, you can just assess the health of your end mill and whether or not you need to compensate for the cutter's tip being gone. And then basically branding iron's done. That's the raw surface finish with the 274Z 1/8 inch end mill. You can polish this up. If you tram your spindle, you can get it a little bit better. My Shapeoko been neglected for a couple months. I'll get to that at some point. But even without really worrying about it, it's plenty good enough to work its magic in wood. When you're heating up a branding iron, you're trying to look for a slight color change. So once it picks up a little bit of a reddish patina, that means you're getting close to the right temperature. And you should always keep a scrap piece of wood around just to test it out, just to make sure that it's branding appropriately, the temperature is right, whatever. Right now my branding iron is attached to a piece of 1/4-20 threaded rod. This is a bit long, it's a little unwieldy, so I would suggest maybe about 6-7-ish inches and then a handle. This is just, it's a little awkward to maneuver. And then this is the back of the topographic carving. It's not quite centered because I was rushing it and I didn't use any sort of guide to align my branding iron. But that is how you would make a really simple branding iron in Fusion 360. Out here for, I'll show you the toolpath with the rounded permutation with the 202 ball end mill finishing the sides. I used a, let's see, a roughing pass enabled. So I have 2 step overs, 0.007 inches apart, and then a final finishing step over of 5 thou. And so that'll make the end mill come down the first time, clean up some of the roughness left by the adaptive toolpath. Second one, just in case there's anything left. And then the third one gives us that final, not quite mirror finish, but pretty good finish. If you take a look at the end mill again, or the branding iron, there, it's got some tool marks, and that's just, it's not going to be perfect. But this side was also the worst one because I was coming in a little hot. That toolpath, I eventually reduced the feed rate to about 50% of what it should have been. So it was 15 inches per minute. I brought that down to about 8 or 7. I'm going to make this file available. I'll just post a Fusion link after this is all done, so you can just sort of deconstruct some of the feeds and speeds that I used for the adaptive toolpath. It's obviously much faster than something like a pocketing toolpath. Actually, in this one, this was a finishing pocket, so it's actually just as fast. But I'll make this example available to you guys. And do we have any questions so far? Since the front right is valuable real estate on my machine, can the bit setter use the back right near the home position? You can, because in Carbide Motion you can set the coordinate of the bit setter to be anywhere. You can put the bit setter wherever you want. So if you just take a little bit of scrap angle line or something and clamp the bit setter to that, you can place it anywhere on the machine that's reachable. The only thing is the currently the tool change positions are hard coded, so it's always going to move to the front of the machine where it's clear of like the wasteboard so that you can change tools and then go all the way back. One day, if I can convince my boss, we could maybe change that, but right now that's sort of our first pass implementation, and it's just the area where we know like there's plenty of room underneath the cutter. Let's see, can you mill brass with a standard Z-axis? Yes. In fact, I think I showed this last time, but I have a 5-in-1 branding iron that I made a long time ago, and 2 of the faces were machined on the Shapeoko. And that was, let's see. So I had 2 faces on like a rectangular piece of stock that was too tall to fit on the Nomad. So I had no choice but to clamp it in a really sketchy fashion in a vise. That was just me squaring up the vise. Machining brass like this, do not recommend. It's a little sketchy. So that is the stock Z-axis belt drive machining brass. When you're machining metals, the big thing to remember is you want to make actual shavings or chips. You don't want to go so slow that you're grinding it away like a Dremel. So if you can sacrifice a little depth of cut to be able to keep your feed rate to a near optimal value, you can basically machine brass with anything. It's just at some point you have to reduce your depth of cut so much that it's just not practical. But even then, like I still managed to get both ends of this branding iron done on a Shapeoko. Came out pretty good. It's not nearly as sketchy on the big drill press vise, but the Carbide 3D vise, it didn't provide enough surface area to clamp on, so you could always just move that piece of brass stock. If you have enough room to put a bigger vise, great. If not, you'll have to find a way to improvise. I could have also clamped this piece of stock to a 1-2-3 block and just gotten a little more surface area between the jaws of the Carbide 3D vise. That might have worked. So we are actually pretty close to an hour. I'm happy to field any additional questions. The link to the Fusion file for an example branding iron will be in the description after this live stream is concluded. Let's see, I'll give it a couple seconds. Let's see. Why wouldn't you want to use a regular flat end mill? So you can totally use plain carbide end mills uncoated, and they will work just fine. The zirconium nitride coating it gives you just a little bit of, like, it increases your probability of success because if your chip evacuation isn't good, if like you're cutting a really narrow channel and chips are just getting packed in there, you can clog an end mill. You can get aluminum or brass just fusing itself to the cutter. The zirconium nitride improves the lubricity and the hardness of the cutting edge just a little bit to give you an extra advantage. But if you use like a couple drops of WD-40, you can usually get by just fine with plain carbide. Flood cooling, one day. It's just hard to do that on an MDF table because it will absorb into the MDF. But if you had an aluminum table, you could totally do that. JPL Richard does that as well. You can find him, say hi to him in the chat. Let's see. Do I like the Makita over the DeWalt? It's really personal preference. I would also throw the Carbide compact router in there because that's what we offer. They all function the same. The runout it's not as good as a proper spindle, like a VFD if you get. So it is like a general purpose tool, and they all work great. They have their pros and their cons. The DeWalt having that LED is nice, but that's basically it. I like the Makita and the Carbide compact router because it's just narrower. Sometimes when you're trying to like pull the DeWalt out of the mount, like it can, especially like if you have, like when I used to have the socket, like those arms would always get in the way. The DeWalt is much fatter, so it's harder and bulkier to maneuver around. The Makita and the Carbide compact router are just smaller form factor rise, so You can also sort of just tilt them to get the cord that comes out sideways a little further out of the way. Let's see. Am I wearing pants? I am wearing pants. I'm wearing jeans currently, even though I could probably wear shorts because it is 68 degrees and sunny outside. Is there a good way to improve cut depth with Z Plus to use smaller end mills without having to stack up layers of the spoil board? If you really need to cut that deep, the best you can do is just to lower the router in the mount as far as you can. You could get an extra long end mill, but there comes a point where you really don't want to do that, because if you imagine the gantry, the spindle, and a tool that's way out like a foot down, there's a moment arm. There's torque that happens when you're cutting. And the further your end mill is from your x-axis rail, the more torque is going to be imparted to your carriages, to the V-wheels, and you're going to get more deflection. So the quality of your cut's going to decrease the longer a tool you use, the more routers stick out you have. So ideally, you want to cut as shallow, like elevate the part as much as you can, and reduce how much your router is sticking out of the mount. Let's see. Do we offer a brushless router? We do not. So currently, it's just basically a regular router, a little cheaper than the Makita, because we don't include some of the accessories, and we also add in additional brushes because we know they are consumable. And then there's an extra long cord to plug it in, because on an XL or a double XL, you've got to run it along the gantry and then to a power strip. So it's just a lot easier to have that extra long cord instead of running a really sketchy extension cord. Topic for another day. Additional thoughts on the vacuum holder for round objects, things you do different. So I think you're talking about the vacuum chuck that I made. It works. There's really not a lot I change about it. Vacuum is vacuum. It will apply vertical clamping force to a part and pull it down. Let me see if I can pull that up. Let's see. I can show you some of the specifics about its design. So this is sort of the base of the vacuum fixture that I designed. It's a 3x5 inch block of HDPE that Carbide sells. So basically, I manually drill in a hole from the side. I tap that for a 1/4 inch NPT. There's a little cavity and an opening to distribute vacuum pressure. And then I just throw a sheet of thin MDF or something on top of it with additional things that will lock in whatever I'm throwing on top of it. So I had a MDF piece like this. I drilled a hole through this panel, and that just pulled vacuum into a cavity that was sitting on top of this. If I were to do it differently, I'd probably replace this whole thing with something that wasn't MDF, something non-porous, maybe another piece of plastic. And then, yeah, that's probably it. Ran an electrical outlet above my machine for the router, works great. Yeah, if you can get an outlet closer to the machine, that's great. Just be careful if you're machining aluminum. Chips will get into basically any nook and cranny that you provide it. So the mill will bend. So everything about machining, especially on desktop machines, you need to scale your cuts to what the machine can do. This isn't a Haas. You can't cut like 1/2 inch deep at a time. So as long as you choose your depth of cuts so that the violence of the cutting action is within what your machine can handle, it's just you pick a slow and steady toolpath, you run it to the end, and you'll get there. It might just take a little longer. But if you can reduce the tool stick out, reduce the router stick out, you will have a easier time and be able to push a little bit harder. Okay, so I think that just about covers it. So thank you guys all for tuning in. I hope you guys stay safe. We'll see you again next week. Hopefully we'll have another fun project for you. Feel free to drop in the forums any suggestions for projects. Always looking for just more project ideas, because eventually I'm going to run out of ideas. And yeah, thanks for tuning in, guys. Also, wearing jeans, so just so you know. Bye, guys.